Okay, I want to talk about the graph of a function and the graph of its derivative. So I have this function here. It's a cubic function, polynomial. And if we have this function, we understood from the last video that I can make a new function, which is its derivative. So the new function is going to be called f prime of x. If I give you an input x, so say I give you the input, -1, then what do? Is I take the derivative of this function, sorry, -1's here. I take the derivative of this function f at that point, -1, and that's the output of my derivative. Okay, so the derivative function is measuring, at each input, it's measuring the derivative of this red curve, okay, this red function here. And we talked about in the last section, we talked about how the derivative is, the derivative of a function at a point is the slope of the tangent line at that point. So you can think of it as the slope of the function at that point, or how fast the function is changing at that point, right? And so if I take an input x, I can go to the x coordinate here and look at this graph. So let's say I take the input 1, so I'm somewhere around here. I look at this graph, this red graph here, and the derivative function should measure the slope at this point. So my new function is going to measure the slope of the tangent line of this red function, okay? And so we can think about what should this derivative look like. So if I graph the derivative, it's a function, right? So I can graph it. And if I look at the graph of the derivative, what is it going to look like? Okay. And I mean, let's start sort of basic. Let's start, it is the derivative function, will it be above or below the x-axis? So is the derivative going to be positive or negative, right? That's what it means graphically. If it's above the x-axis, then the function is positive. If it's below the x-axis, then it's negative. And so how can we measure this? Well, the value of the derivative, so the y value here, is going to be given by the slope of this red curve, right? That's the definition of my function f prime, is the slope of this original function f. So if the slope is positive, then the derivative function is going to be above the x-axis. And if the slope is negative, then the derivative function is going to be below the x-axis. So I think in this example, you see that the red function is increasing when x is less than 0. So I think when x is less than 0, our derivative function is going to be up here somewhere. And then you see the function is decreasing when x is between 0 and 2. So this red function is decreasing when x is between 0 and 2. And so I think the derivative function is going to be down here. It's going to be negative. And then it increases again. So it's going to be up here when x is bigger than 2. So let's see this. Let's see if our intuition is correct. So Desmos can just graph the derivative function for you. It's very nice. And it's what we said is true, right? So when x was less than 0, this derivative function is positive. It's above the x-axis. When x is between 0 and 2, the red function was decreasing, and so the derivative function is negative. It's below the x-axis. And then at x equals 2, the red function shifts again. It becomes increasing again, and so the slope is positive again. And so this function, this green function, goes above the x-axis again. Okay, and now you can think about what does it mean for the green function, the derivative, to cross the x-axis. So when is the derivative 0? Well, that means if the derivative is 0, that means the slope of the tangent line on the red function should be 0. And that means, like, if I did the tangent line to this red function, it would be a horizontal line, right? That's a line that has slope 0. And you can think about where would that happen on the red function. So let's mute this for a second. On the red function, where is the tangent line going to be horizontal? Well, it's sort of right here, and right here. It's where it shifts from positive from increasing to decreasing, right? And so if we look at the derivative again, that's exactly what happens. The roots of the derivative are at 0 and 2, right where the original function changes from increasing to decreasing or decreasing to increasing. Another thing that you can think about is not just whether the derivative is positive or negative, but how large it is, right? So sort of down here close to 0, like a little bit less than 0, the derivative is positive, but it's not very positive, right? So it's just a little bit above 0. And what does that mean? That means the slope of the original function is positive, but it's not very large. So if you think about what that means, it means that the function should be increasing, but the tangent line should be not very steep, right? And so if I look at the rate of change of this curve here, that's what's happening, right? It's increasing, but it's sort of increasing only a shallow amount, right? Whereas if I go down here, the function is increasing and it's quite steep, right? And if what that means on the graph of the derivative is that, well, the derivative should be positive, and actually it should be quite large, right? If this is very steep, then the slope is a large number. And so that's what's happening is as I get more negative, as I get more negative in x, the value of the derivative is getting larger and larger, right? It's getting larger and larger. And the same thing on the other side, right? So as x gets larger, this red function is getting steeper and steeper. And so the y value of the derivative is getting larger and larger. And there are some other things that we can understand about what the shape of the derivative should look like based on the shape of the function, and we'll talk about that soon.